Hello everyone. Today we are gonna learn how to calculate normality, equivalent mass and n factor. So, without any further delay, let's dive straight into the video. Normality is represented as capital N and its formula is given mass of solute into 1000 by equivalent mass of solute into volume if it's mentioned in ml. Do remember that if in the question the volume of the solution is given in terms of liters, then you don't have to mention 1000 in those cases. For those who have an issue in understanding solute and solvent concept, note that solution is divided into two parts, solute and solvent. Solvent is represented as A and solute as B. For example, salt plus water forms salt water or the solution. Here, salt represents solute, that is B, and water represents solvent, that is A. Do remember that the amount of solvent is more than solute in general. That's why the formula of normality is written as WB, that is given mass of solute, into 1000 by equivalent mass of solute, that is EB into volume if in ml, and WB by EB into volume if it's mentioned in liter. Here E represents the equivalent mass, and the formula for calculating equivalent mass is molar mass upon n factor. So now let's talk about equivalent mass in detail. The equivalent mass of an element is calculated by its atomic mass upon its valency. For example, in case of sodium, its equivalent mass is 23 by 1, where 23 is its atomic mass and 1 is its valency, and in case of magnesium, it is 24 by 2, which is equal to 12. So now, moving on to ions. The formula for calculating equivalent mass of ions is it molar mass divided by the charge present in it. For example, the equivalent mass of Na plus is 23 by 1. In case of O2 minus, the equivalent mass is 16 by 2, and in case of CO3 2 minus, the equivalent mass is 60 by 2, that is 30. So now, moving on to acids, the formula for calculating equivalent mass in acid is its molar mass divided by the number of replaceable H plus ions. For example, the equivalent mass of HCl, that is hydrochloric acid, is 1 plus 35.5 upon 1. The 1 is due to the presence of hydrogen. And in case of H2SO4, the equivalent mass is 2 plus 32 plus 64 by 2. Calculating the number of replaceable H plus may not always be as easy as it seems. So, to be sure that your answer is correct, you need to make the Lewis structure before. For instance, here you can see that in case of H2SO4, two hydrogens are attached to oxygen, which means they can be easily replaced. That's why in H2SO4 the number of replaceable H plus is 2. So now tell me, what is the number of replaceable H plus in case of H3PO3? If your answer is 3, you are wrong. The answer is 2. All you have to do is simply draw the Lewis structure. In case of H3PO3, you may notice that 2 out of 3 hydrogens are attached to oxygen, whereas 1 hydrogen is attached directly to the phosphorus. Since the 2 hydrogens aren't attached directly to the central atom, they can be easily replaced. Similarly, in case of H3PO4, the equivalent mass is m by 3. I want all of you to answer the equivalent mass of H3PO2 and H3BO3. Make sure that you mention the answer in the comment section below. Now, let's move on to another tricky question that may be helpful for your entrance exams, which is calculating the equivalent mass of H3PO4. And your options are m by 1, m by 2, m by 3 and all of these. Here, m stands for molar mass. Here, you may think that the answer is m by 3, that is the third option, but you're wrong. The correct answer is all of these. Because in case of acids, the n factor represents the number of replaceable H+. If you draw the structure, you may notice that either one H+ can be replaced, two H+ can be replaced, or all the three H+ can be replaced. So that's why the correct answer is all of these. So now, moving on towards the last part of the video, which is calculating the equivalent mass of a base, and its formula would be molar mass divided by the number of replaceable OH minus ions. For example, in case of NaOH, its equivalent mass would be m by 1 because of the presence of one OH with Na, and in case of FeOH whole 3, its equivalent mass is m by 3 because of the presence of 3 OH with Fe, and in case of NH4OH, its equivalent mass is m by 1 due to the presence of 1 OH with NH4. But what will be the equivalent mass of NH3, as there is no OH present over here, but its equivalent mass is m by 1, and 1 due to the presence of one lone pair present on nitrogen. So that's all for today's video. Thanks for watching, and feel free to mention your doubts in the comment section below.